We're going to do some equation solving today, but first a quick little reminder. If you have a logarithm is just the power that you raise your base to get the value that's inside. So we're thinking about 2 to what power gets you 32. If you try a few things, you'd end up with 2 to the 5th power gets you 32, so our power or our logarithm is just equal to 5. So I like equation solving. If you're solving an equation, you want to get the exponential functions to have the same base if you can, and if not, use a logarithm. So if you look at these, they both have base 15, so to make both sides of that equation match, I just need my exponents to match, so x has to equal 2. This one has different bases, so think about 9 is a power of what number, 27 is a power of what number. I need to rewrite these using the same base, which I could do 9 as 3 squared, because that's still equal to 9, and I could rewrite 27 as 3 to the 3rd, also still equals 27. Then I have my exponents of 2x and x minus 1 on those. So rewrite them with the same base, and then use your exponent properties. So I will multiply my exponents together, so 2 times 2x, and then 3 times the quantity x minus 1. Make sure you have your parentheses there and distribute that 3 when you multiply. So you end up with 3 to the 4x power equals 3 to the 3x minus 3 power. Now that the bases are the same, you just need to figure out what value of x makes your exponents equal. So set your exponents equal to each other and solve. You got 4x equals 3x minus 3. If you subtract 3x from both sides, you're just going to end up with x equals negative 3. So that's it. Rewrite them with the same base, set your exponents equal. So let's think about using base 3 again. 3 squared is 9, so 3 to the negative second is the same thing as 1 over 9. So if I rewrite that as 3 to the negative second, it equals my original, and it now has a base of 3. Multiply your exponents together, which doesn't do anything on the left. On the right, you have negative 2x minus 6. And then again, you want to set your exponents equal to each other because the bases of your equation already match. So do x equals negative 2x minus 6. Add 2x to both sides, gives you 3x equals negative 6. And then you could divide by 3 and end up with just x equals negative 2. How do I solve an exponential equation if I can't just guess and check whole numbers? Well, let's do the log that matches the base on both sides. Exponential functions and logarithms are inverses, kind of like you square root something that's squared. We're going to do log base 9, since this is a base 9 exponential function, which those will undo each other. You'll just get x on the left equals log base 9 of 35. And then that's not a whole number, so we're going to use our change of base formula from yesterday and do log of 35 divided by log of 9 in a calculator, and you should get approximately 1.6181. If you have something else involved with your exponential function, you want to get your exponential part by itself first before you do a logarithm. So I'm going to divide both sides by 100, which is just going to give me my exponential part equals 2. Now use the logarithm that matches the base of your exponential. So do log base 1.02, even though it's ugly, of both sides of your equation. And by doing that, on the left-hand side, you just get your exponent back of x over 4. I'm just going to leave the right-hand side as it is for a minute. I'm not solved for x yet. I need to multiply both sides of my equation by 4, which will make it x equals 4 times that logarithm. Now let's actually approximate it. So if you use your change of base formula, you'd have 4 times log of 2 divided by log of 1.02. Punch it in a calculator. People tend to screw these up in calculators, so just be super careful with all your parentheses. You should get approximately 140. Let's think college tuition for a second. So say that cost of college tuition in 2018-19, on average was $7,000 a year. We want to figure out how long it will take for it to quadruple. Kind of a scary thought. Since it's continuously increasing at a rate of 6%, we're going to use our continuously increasing, looks like our interest formula, works for the same thing even if it's not money. So our rate is going to be 6%. The starting cost is $7,000. And we're looking for an ending amount of tuition that is quadruple our starting amount. So I kind of color-coded, highlighted things here. So quadrupled tuition, if we started with 7,000, take that times 4. That means we're looking for how long it takes us to end at a tuition of $28,000. So P is our starting amount of $7,000. E needs raised to the power of 0.06 times t. And then we need to solve for t. So get your exponential part, your e to the 0.06 t by itself, divide both sides by 7,000, which is just going to give you 4. And then to solve that equation, I need to undo my exponential function by taking a log of both sides that matches my base of my exponential. So this is base e, so I'm going to do log base e of both sides of my equation, which you might remember is the same thing as natural log. We've got a special notation for that one, so I'm going to actually write this as natural log of 4 equals, they will undo each other, and you will just get 0.06 t. I could get the decimal for natural log 4. I'm just going to go ahead and divide both sides by 0.06. And then if you use your calculator, you have natural log programmed into it already, so you can do natural log of 4. Make sure you close your parentheses and then divide by 0.06. Should give you approximately 23.1 years for tuition costs to quadruple, which is still kind of scary.